Before taking a plunge into the pool of adhesives, let's try to, since we have already studied the coating, so let's try to understand the basic difference between coatings and adhesives. Usually, we know that the binder of the coating serves the purpose of binding the coating to the substrate. So the binder plays the role of an adhesive over there, but no, there is a difference between coating and adhesives overall. How? Let's try to understand. A coating, it should adhere to one substrate. You apply the coating on the substrate, so it is that substrate only which the coating is responsible to bind to. Whereas an adhesive, when applied, it should adhere to the one substrate wherein it is applied, and when I want to put another substrate over this first one, I want to join those two parts together by applying the adhesive in between. So the function, the role of adhesive here is to adhere to one substrate and then to the second substrate which is applied over the first substrate. So it is playing a dual role over here. It is, let's say, it's playing the role of adhesion twice over here, lower and upper side both. A coating, when it is applied, it dries up, it solidifies, forms a uniform thin film, and then it is exposed to the harsh environment, to the heat variation, temperature variation, to the moisture, to the different gases, to the different solvents, to marring and abrasion. So the coating has to overcome all these hurdles, all these problems. It should be able to withstand all these problems of abrasion, solvents, water, temperature variation, marring, etc. So, and also it should have a high gloss, and along with these special properties, and that gloss should not become pale or dimmer with time. So that is the second function of coating. Whereas an adhesive, oh my god, it is safe from all these hustle and bustle. So an adhesive is it is protected, on the other hand, by another substrate. Because why? Because it is being sandwiched between the two substrates. So there a adhesive is being provided in a way indirectly with a protection cage, which the coating is not actually. So it therefore does not have some of the performance properties that must be built into a coating, so adhesive can escape those parts, those properties. It's safe over there. And but yes, it must ideally have a bond strength which is high enough to even to fracture or tear at least one of the substrates. So in many cases, what happens, the bond strength should not be materially affected by heat. The bond strength of the adhesive should not be affected by solvent or water. So therefore an adhesive must not only have a good bonding, a good anchorage, a good let's say chemical forces to both the substrate, the adhesive strength, it should also have high enough cohesive strength, the strength which binds the similar molecules together, so that when we try to pull off or delaminate the adhesive, it is able to fracture or tear one of the substrate upon delamination. This shows that there was a strong bonding between the adhesive and the substrate, because whenever there is a strong bonding, then only the adhesive will not be able to come out. So an adhesive must balance adhesive strength with the cohesive strength as well. So that's another difference. Next basic difference between the coatings and adhesive is in their film formation properties. We want to have a hard, a sticky, free and heat resistant coating. I don't want my coating to be sticky. I don't want my coating to be tacky. I want it to be tack free. I want a hard, a uniform, a thin uniform and glossy and heat resistant coating. For that purpose, I need to select the polymer with a higher glass transition temperature than the room temperature. So its glass transition temperature should be higher than the room temperature, otherwise your coating will disintegrate slowly and gradually. So the coating then requires a coalescing agent, so that it can form a continuous film, it can form a clear continuous films. But adhesive, they form the films at room temperature without the need of any coalescing agent. They do not need any such coalescing agent. So therefore we can select a soft flexible polymer film for an adhesive, which should be thermoplastic. Yes, of course. Uh, it should be able to soften, it should be able to flow repeatedly upon the application of heat. That should be a property of the polymer chosen for the adhesive. The film can subsequently, yes, of course, be cross linked through functional groups if the heat and solvent resistance are required in future. So these are the sole differences, the main differences between coatings and adhesives on the basis of their primary function, on the basis of their exposure to different environment, on the basis of their performance requirement, what is required from them, what is the demand from them, on the basis of the bond strength, on the basis of film formation, the glass temperature of the polymers which are used to prepare the adhesives and the coatings, and the cohesive strength, and yes, of course, the applications.